February 24th, 2007. Helmand Province, Afghanistan. Chief Warrant Officer 3 Dave Carter is flying his Apache attack helicopter on a combat patrol when every warning system in the cockpit lights up simultaneously. His aircraft has just been hit by a rocket-propelled grenade, then another, then 5 more in rapid succession. Over the next 90 seconds, his Apache will absorb 29 direct RPG hits and hundreds of small arms rounds. He lands it, and the way he survives reveals why the Apache is the most resilient helicopter ever built. Carter and his co-pilot gunner are flying low-level reconnaissance over a known Taliban-controlled village. Intelligence suggests weapons caches, but the mission is observation only. Stay high, stay fast, stay safe. Except the Taliban have other plans. They've set up a textbook ambush, RPG teams in multiple buildings, coordinated fields of fire, pre-positioned for maximum effect against helicopters. The first RPG comes from Carter's 9 o'clock low. It impacts the left stub wing exactly where the Hellfire missile pylons attach. The explosion tears through the wing structure but misses the fuel tanks by inches. Carter immediately banks right to unmask the gun and get eyes on the shooter. That's when the second RPG hits, this time striking the tail boom. The impact sounds like a car crash. The helicopter shudders violently. Standard procedure says break contact and egress. But Carter's got a problem. He's over a wadi, surrounded by high ground on 3 sides. Every direction he turns, there's another RPG team waiting. 3rd hit, 4th, 5th. The cockpit is filling with smoke. Warning lights are cascading across the display. The Apache's AN/APR-39 radar warning receiver is screaming about multiple threats. Here's what's keeping them alive. The Apache's designers assumed the helicopter would operate in the most hostile environments imaginable: close air support in Soviet-occupied Europe, low-level tank hunting where every enemy position has guns pointed skyward. So they built the Apache to absorb damage. The airframe is designed to survive 23mm cannon hits. The fuel tanks are crash-resistant and self-sealing with foam baffles that prevent catastrophic explosions. The engines are separated and shielded to prevent a single hit from taking out both. The rotor blades can take multiple hits and keep turning. Most critically, all flight-critical systems have redundancy. Dual hydraulic systems, backup electrical. The tail rotor driveshaft is inside an armored tube. RPG number 7 hits the transmission cowling. This should be catastrophic. The transmission is what transfers power from the engines to the rotor system. Lose the transmission, the rotor stops, you fall out of the sky. The Apache's transmission is designed to run dry for 30 minutes, even with complete lubrication failure. It's a solid chunk of aerospace-grade steel that can absorb impacts that would shred a normal helicopter gearbox. Carter's still flying, still fighting. His gunner has identified 3 RPG positions and is engaging with the 30mm chain gun. The weapon fires 625 rounds per minute of high-explosive dual-purpose ammunition. Each round can punch through brick walls. RPG number 12 hits the left engine. The turbine immediately starts to fail. Engine fire warning, rotor RPM dropping. Carter shuts down the left engine and goes to single-engine power. The Apache can fly on one engine, but it's marginal. He's lost half his power in high-altitude, hot conditions. The helicopter is barely maintaining altitude. Hits 13 through 18 come in a cluster. The Taliban have realized the Apache isn't going down easily, so they're just throwing everything at it. RPG teams are firing from multiple buildings simultaneously. One RPG goes through the cockpit canopy between Carter and his gunner. It doesn't explode, just punches through the armored glass and exits the other side, leaving 2 holes and a rush of air screaming through the cockpit. Armored glass, 1.5 inches thick, rated to stop 23mm armor-piercing rounds. The RPG warhead hit at an angle and skipped off instead of detonating pure luck, but the glass held long enough to deflect it. RPG-19 takes out the forward FLIR sensor. The targeting system goes offline. Carter's gunner is now firing the gun using backup iron sights, like a World War II bomber gunner. Hits 20 through 23 shred the tail boom. The tail rotor is barely functioning. The helicopter is yawing uncontrollably. Carter is fighting the pedals, using every bit of remaining tail rotor authority to keep the nose pointed forward. Here's the critical moment. Carter realizes he can't climb out of the wadi. He doesn't have the power. The helicopter's too damaged. If he tries to gain altitude, he'll stall and crash. So he does the opposite. He descends, gets down in the dirt 20 feet off the ground, and flies straight down the valley at 100 knots, using terrain to break line of sight with the RPG teams. This is insane flying. He's got one engine, a shot-up tail rotor, smoking hydraulics, and he's threading the helicopter through a narrow valley at high speed with barely enough power to stay airborne. RPGs 24 through 29 hit during the egress. Most impact the tail boom, which at this point is more holes than structure. One hits the remaining stub wing. Another takes out the right landing gear. Carter clears the wadi and gains enough altitude to limp towards the forward operating base. The helicopter is vibrating so badly, the instruments are unreadable. Oil pressure is dropping on the remaining engine. The low rotor RPM warning is beeping constantly. He makes it 12 miles before the transmission temperature hits critical. The remaining engine is overheating. The tail rotor is barely providing any anti-torque control. Carter spots an open field and makes the decision. Emergency landing now, before something fails completely. He brings the Apache down hard. The right landing gear collapses on impact because it's been shot off. The helicopter tips onto its side. Rotor blades strike the ground and shatter. The fuselage slides 30 feet and stops in a cloud of dust. Carter and his gunner unbuckle, kick open the canopy, and run. They expect the aircraft to explode. It doesn't. When the recovery team reaches the Apache 2 days later, they count 29 RPG impact sites and over 200 bullet holes. The tail boom looks like Swiss cheese. Both engines are destroyed. The transmission is cracked. One landing gear is gone. The FLIR is obliterated, but the fuel tanks didn't explode. The rotor didn't separate. The cockpit structure held. The pilots walked away. The aircraft was airlifted back to a depot and evaluated. The damage assessment: total hull loss. Uneconomical to repair. Except the Army did repair it, because the airframe itself was still structurally sound. 6 months later, that Apache was back in service with a new tail boom, new engines, new transmission. Here's why this matters. Helicopters are inherently fragile. They're complex machines with thousands of moving parts spinning at high speed. A single component failure can be catastrophic. The Apache was designed to defeat that fragility through redundancy and armor. Every critical system has a backup. Every vulnerable component is protected. The aircraft is designed to lose parts and keep flying. During Operation Iraqi Freedom, Apaches flew into conditions that should have been suicidal. low-level penetration missions into heavily defended areas, close support in urban terrain where every building had an RPG team. They took hits, lots of them, but they kept bringing crews home. Dave Carter's flight became a case study at Fort Rucker, where Army pilots train. The mission profile is analyzed, the damage patterns studied, the decisions evaluated. The conclusion: the Apache did exactly what it was designed to do: absorb punishment, keep flying, and give the crew a fighting chance to survive. Carter was awarded the Distinguished Flying Cross. His gunner received the Air Medal with Valor. The Apache, tail number unknown because the Army doesn't publicize specific airframes, flew for another decade before being finally retired. The AH-64 Apache is still the U.S. Army's primary attack helicopter 47 years after its first flight. It's been upgraded, modernized, and improved, but the fundamental design philosophy remains: build it tough enough to survive the worst day possible. Because in combat, your worst day is the only one that matters.